Hi, my name is Kyle Kerger. I'm a master's student at the University of Iowa in the Science Education program. For my master's, I put together this unit plan for Dr. Mary Skopek at the Iowa Lakeside Laboratory. This unit plan is on the subject of glacial geomorphology and how the geologic setting of the Iowa Great Lakes region impacts the way water travels throughout that area and therefore how contaminants can travel through that area. So my goal behind these videos is to kind of explain how to best use this unit and the lessons I've included in it, the resources I've compiled, and just kind of the way I imagined it going. I know that when I look at my lesson plans, I know exactly what they mean, but somebody else looking at it, it might not make as much sense to them, which is why I have these videos put together. And so it's going to be going over my thoughts on each one of these lessons, how they interact with each other, the resources we have, kind of a walkthrough, and then what it might look like for some of your students. So what we have right here is I've put together 6 hard concrete lessons and then some resources that have been compiled that I use to make it, doing some of the research behind it. So I've included them for you all as teachers as well. But what we're going to be doing is going over the way I envision each one of these working. If you like the way I kind of saw it going in my head, that's fantastic, and you want to use it, great. If you want to tweak it a little bit, if you like some of the things but you want to add or take some things away, that's awesome. And if you take a look at the lesson and you're just like, I don't really like this, I don't really like the way it works, that's totally fine as well. Please feel free to take and use these as much as you want, bits and pieces, any of the resources, reshape them. This is meant to be used for you and the benefit of your students' learning. So what I have real quick, my idea is that I'm going to make a video for each one of the lessons. So since this is kind of the introduction video, I'll go over the kind of the general unit plan and then save the finer details for the other videos we'll put together. So this lesson is, like I said, over glacial geomorphology. I've geared it mostly towards high school students. That's not to say it couldn't be scaled for middle school students or even younger learners as well. But as the lessons progress and build on each other, it really does get into more of a kind of a research background kind of there. And so I think it's going to be more and more difficult for younger learners to be able to perform at the level you want them to. So that's why I focus it mostly towards high school students and say that it's mostly for them. With that, just some kind of background assumptions that I had when I was putting this together. This is over glacial geomorphology, which if you're thinking about the Earth history, glaciation was really kind of the last 30,000, 50,000 years, especially in Iowa. So if you're thinking about that as the whole Earth history, that's really like the icing on the cake, the last layer. So when I created this unit, I imagined that it would go towards the end of either a semester or a year-long high school geology or earth science course. With that, I'm operating under the assumption that students have a fairly decent understanding of the fundamentals of geology. So the rock cycle, the types of rocks, plate tectonics, and then general earth history. Without having kind of those 4 key things before going into this unit, I think it's going to be kind of difficult for them to understand. It's not to be said that you couldn't start with this or just do this as a standalone unit, but it's kind of, you'd be really working backwards in your Earth history there, and I think it wouldn't be as beneficial. I think this works better at the end of that, provided they already have that understanding. So I designed it under that assumption. It's not to be said that you can't. You're just going to have to add a lot more of your own supplemental lessons, and you're going to end up kind of taking side tracks to make up for that prior knowledge if they don't already have it. So with that, it's mostly earth science, but it does have quite a bit of life science tied into it. As far as the NGSS are concerned, it was mostly earth and life science. I didn't really find too much of the physical science. You can look into that more if you think it will. But going into this document here, the performance expectations, I designed this around NGSS, or the Next Generation Science Standards. Here in Iowa, those are becoming kind of the standard that people are operating off of. I know that's happening in a lot of other states as well. So I kept that in mind and built it around this. It should work. I found a bundle of performance expectations that I think could be fulfilled by this. And the reason I say could be, it really depends on some of the finer details you might do within this lesson, some of the things you might do on your own or with your class, depending on what understanding they bring into it, how long they take to grasp certain concepts, how far you jump into it and delve into other side paths that could be tied into this lesson and these units as well. And also it kind of depends on what your district counts as fulfilling a performance expectation. So I included a huge long list of them that I think could be fulfilled by this. I said C Annex A because I put it at the end because I didn't want to bog down too much space right here. So the next part we have kind of the big ideas and big questions that I imagine for this unit. You can read those as well. I'll highlight just one of them. The big one that is the underlying question for this unit is, how does the geological setting of the Iowa Great Lakes influence the delivery of water and therefore contaminants to the lakes? So that's going to be your big kind of underlying question, what this unit seeks to try and find an answer to. These other questions are things that you're going to come up with as you go, and I think really do supplement or help you get to that big idea question. I came up with 5. Feel free to kind of add to them or take away from them. The big thing I would say is let your students add to them. If they kind of have these big questions that they start developing, start gearing your unit towards that. That's going to be key. That's going to cause more buy-in from them. And really, they're going to come up with questions you probably never would have thought of. I know they will certainly come up with questions I haven't thought of. The only one that I would say for sure needs to be a part of this is this one that I've highlighted right here. So I'll let you read those on your own. The next section we have is the aspects of the next generation science standards. So what I did here is, like I said, I compiled the list of standards that might be there that could be completed based on this unit. With that, you have your science and engineering principles, your disciplinary core ideas, and your cross-cutting concepts. All I did was under each standard, I went to the site, highlighted kind of the different concepts here. So like your cross-cutting concepts, your DCI, and your SCP, and put them in right here so you can read them all individually. There was kind of some of the formatting, since some of them would have a longer science and engineering practices, maybe only one disciplinary core idea. They're not necessarily in line with which standard they're with. If you want to see those, click on the standard itself. But as you can see, there's quite a bit of concepts and content here that we're going to be delving into with this unit. So these are all different things, like I said, I think could be fulfilled based on this unit. A lot of potential here. So there's just some information for you to read those specifically. Like I said, if you want to see it in which standard it's tied to, just click on the standards that I've included. Here we have just kind of a quick rundown of what the initial engagement activity is. So to introduce this unit, the initial engagement activity is the first lesson. So I'll wait until we do that video to really delve into what I envision for that. But there's just kind of a quick rundown of what that is. The potential questions, these are questions I think students might ask, and then ways I think we could answer them using what's already in the unit. Like I said, students are going to come up with things you never would have thought of. Use their questions to help guide the unit and come up with answers as well. So this section right here is potential argument-based learning that I've included in this unit. So I have 2 lessons that I think really lend themselves well to argument-based learning. I don't want to get, like I said, I'll wait until those videos to really get into the nitty-gritty on those, but these are kind of the questions that each one of those lessons kind of asks, and then how you could go about making it argument-based learning, or the science writing heuristic if you're familiar with that. So that's kind of how I envision that going. It's, again, very brief. As far as STEM integration into this unit, we have plenty of the science from talking about glacial geomorphology and hydrology and human interaction on the environment. These are just some ways I thought the other aspects of STEM could be tied in. So for mathematics, they're going to be gathering some data and some investigations. They're going to be doing some interpretation of some data and some numbers. And then really there's a huge section on the students analyzing economic costs of some of the things that are going on, which is not necessarily related to like calc or trig or whatever, but That's a huge section of mathematics that really is relevant to students and society as a whole, is the economic factors that go into it. So I've included that there. As far as technology, I'm not a big fan of just throwing in technology just to throw it in, or doing simulations just to do them because we can't get out of our Chromebooks enough. It, Students are going to need internet access to make this unit possible, whether that's at the school in a computer lab, or if it's one-to-one, or possibly even at home or at their local library. As far as new technology, though, students are going to get to use LiDAR imaging, which, if you're not familiar with that, don't worry, another video for that as well. They're going to get to use that, which is a new form of technology that they've probably never seen before. And as far as engineering is concerned, a lot of the engineering we're going to be doing is environmental engineering, specifically with ideas to like farm practices, and then like hydro engineering, and where we move water and how we impact that. This is just kind of a quick rundown on the kind of what I imagine the summative final assessment being. It's going to be a presentation, kind of city hall style. As far as community connections, this is, if you're from the Iowa Great Lakes region, this is all about where you guys are from. So this is tied to your community all the way through, as far as like what's around you, some of the societal impacts. It is 100% completely tied to you guys. So if you're from that area, the whole thing is a community connection. If you're not, if you're still from somewhere else in Iowa, a lot of the societal issues, especially with like pollutants going into water, is going to be across the state. And I mean, depending on where you're at in the state, the chances are if you're in the northern or central region, you were glaciated as well. It's very prevalent in the Iowa Great Lakes region. You can really see the evidence of it. So it is still relevant to other areas in the state. And then if you're not from the state of Iowa, chances are this could be used as a case study for what glaciation is, or continental glaciation, and then how human impact interacting with that geologic setting, what that looks like. I would say this is just really lends itself well to other Midwestern states that have been glaciated. So like southern Minnesota or South Dakota, North Dakota. If you're not from the country, if you're from Canada, if you're from some of those middle provinces, those have been highly glaciated too, so you can take a look at those. Some of the Earth history might be a little bit different because of the bedrock, but it has connections depending on how you want to look at it. And then these are just some examples of some of the resources I used to put together this unit and what resources you might need to do this unit. Each individual lesson plan has resources that you'll need for it, and then I'm including a bunch of the other stuff that I used for research and that your students can use for their own research when they get into those aspects of the unit as well. They're like PDF files and documents that I couldn't really include in here, and I didn't want to make this too long. Like I said at the very beginning, here we have NXA. These are all the standards I thought could have been completed by this unit. I've included some of the middle school standards. Like I said, there's more high school standards that I think it meets, but I included the middle school ones as well if you want to take a look at those. So, in the other videos that we're going to be doing, like I said, this is an introduction. We're going to be going over the individual lesson, what I envision for it, what I envision happening before it, what I envision happening after it, and how it can be used in your classroom. So, in order to figure out more, stay tuned for more videos. Thanks for watching.